Hello everybody, I wanted to share a repair with you that was hard. This is high hanging fruit, not low hanging fruit. This is a board that I feel most shops would have probably totaled, and I'm going to show you why. Coffee was spilled on this. Water damage usually is pretty straightforward. You can find the areas that have the corrosion or have a trace chewed off of it under the microscope, and you can fix that damage. And in most cases, you're in and out of a water repaired board in under 10 minutes. It's not a big deal. In this case, it was much harder. So let's go over this repair. I'm sorry I cannot show these live. I'm looking for a Canon M50 camera so I can mount one, up above my bench and display what I'm doing here. I'd like to get a new microscope, which Lewis is currently out of, that have the proper camera here. I want to use video input from here. I want to use video input from the oscilloscope, and I have got the switcher where I can control my hands and switch. I have the microphone. Right now I need a new scope and I need a few more cameras, and we're ready to go. But for right now, I'm still showing these after the fact, so if you don't want to believe me because you're not seeing it live, that's all right. But I want to go over this board anyway. So this board came in for water damage. They had coffee on it. It was very hard, and I'm going to show you why it was hard. And you can go back through every single video that Lewis has done, and you probably won't see a water damage repair this complex. But looking at it, it wasn't that bad. There was some minor corrosion on it. It did not look that bad. It cleaned up well, and after the cleaning, washing, drying process, and after the trace repair process, I thought we were good. We weren't. So now it's time to use the brain. You can't just look and fix things. Now you got to use the brain. So this is a brain repair for sure. So the first thing that was out, when I plugged in my MagSafe charger, I had no green light. Okay, and if you've been watching these videos of mine or Lewis's, you realize that if you don't have a green light, that means that the SMC chip, which communicates to the charger through the one-wire circuit, this chip here has to have power, and if it does, it's talking through some lines, and those lines go to this ribbon cable, and they come across here, go into this jack, and then when you plug the charger on, there's a couple buffer chips to protect the circuitry from a misplugged charger, but when you plug this charger on, the charger and the SMC, and you can see this on the oscilloscope, they actually talk back and forth. The charger goes, "Hey, I'm here." The SMC goes, "Hi, what do you want?" And he goes, "Hey, I got voltage I want to turn on." The chip goes, "Well, turn it on. This is what we want." And so then the charger goes ahead and activates the 18 volts, and you get a green light. And boom, power's on. So if this communication isn't happening, you're not going to get that green light. So whenever you don't have that green light, you can jump right in to this chip and the 3V42 power supply. So, no green light. What's the first thing you check? The 3V42 power supply. No voltage coming out. Great. Looking at it, there was trace damage. I had to repair this. There was a chip in there I changed and a little line I had to run. So I had to fix this supply. Thinking, no big deal, fix this 3V42 supply. We get a green light, we're good. I fixed the supply, I test it, no green light, nothing. So after this chip, which wasn't getting its power, right here, this is the SMC, and as you can see, this is not a fun chip to replace. There are 157 pads. So this is where every technician goes, crap, this supply is good. It's sending voltage to the PCH. The PCH one-wire circuit is not talking. What do I do? Oh, here it is, one wire. The PCH one-wire circuit, which is that wire that goes up to here, and then that's that ribbon cable that goes over and goes to the power jack down here. So if this isn't talking, and this is getting power, unless you got some nasty water damage underneath here, usually it's the chip. So I'm like, crap, I get to do an SMC repair. How fun. So that's what we did. We changed the SMC. Most shops, a lot of shops, will stop right there and total the board. So these chips you can't buy, you have to harvest. Apple kindly does not sell them to you because they have custom software. If you try and read this chip, it's like a spy that eats a cyanide pill. The chip destroys itself and wipes itself out if you try and read it, which is, thank you very much. Love your show. You know, thanks Apple, appreciate that. There's nothing proprietary about this chip. There's no intellectual property that's super secret classified that somebody doesn't have. This chip just basically turns shit on and off. There is no magic inside here, but you know, they have to make it hard on us. So they wipe out the software that runs this chip, because these are programmable. The people that make these chips sell them blank, and then you can write them for your board to turn things on and off. And there's nothing secret about how this chip works, but Apple won't sell it to you, and they give the chip a cyanide pill if you try and read it. So to get these, it's like a double job, because now if I want this chip, I just can't go get one and put it on. I have to take one off another board. Okay, so I take one off another board, then what do I got to do? Well, Rosalind has some videos on that. This is my SMC reballing jig. So once I get a used chip off a board, because I can't buy a new one, I have to clean the chip, wash the chip, clean the pads off the chip. I touch all the balls and put a little bit of lead solder on it. And then I put the chip under this stencil. And then I put leaded solder paste on there. And then I heat it with my gun and get all the balls to form. And then I take it off because it's stuck to this stencil. And I put it on my heat plate, put flux on it. And then it bubbles off the tray. And I flip the tray off carefully so none of the balls get messed up. And then I take the chip and then I wash it and then I clean it again. And now I've got a chip. So I just spent 15 minutes taking a used chip and making it so I can use it again, put new balls on it. So there's 15 minutes. Then I take the old chip off, put the new chip on, reball it, hope everything goes right. If I mess up just one of those 157 balls, which trust me, it's pretty easy to do, I get to start over. So that's why people don't change this chip. I do, but it's not my favorite thing in the world to do. It's like playing that doctor game with the pair of tweezers, you know, operation. And if it touches something else while you're trying to pull the funny bone out, it goes, and then you get to start over. That's this chip. This chip is like playing operation, you know. So it's not a fun repair to change that chip. But I changed that chip. And after replacing this chip, as I suspected, boom, green light on the charger. Awesome, it's gonna be fixed. I got a green light. I'm looking over at my current draw. It's wrong. It's 300 milliamps. It's not booting, it's just sitting there. I'm like, oh, crap. So what else is broken? I put thermal imaging on the board because I want to watch its boot cycle. None of the RAM lights up. It's not running. The processor never gets loaded, never runs. So I'm like, that tells me it's not loading the BIOS. So then I pull out my trusty tech oscilloscope here. And I look over here, which is this chip here. Keep in mind, this is now the third repair on this board, just to get it working. So I go to this chip here, and I measure, because if the PCH doesn't get a clock, it's not going to work properly. So that's my PCH clock signal. I got to get close so it actually gets the light right so you can read that. There you go. So this PCH clock signal was missing. So no wonder it's not loading the BIOS. Okay, so I look at this chip really close. I see that on the PP3V42 line, and the reason the PP3V42 line is going to be a problem with water damage is because this rail is going to be hot pretty much all the time, because this SMC chip, even when the machine is off, this chip is getting power, because this is the chip that sees the power button. So this chip has to be sitting there looking and waiting for a human being to open the lid or plug in the charger or hit the power button. So this chip is always on, whether you're on battery or whether you have a charger plugged in. This chip is always turned on. And this 3V42 power supply is always on as well. So when you get a water damaged machine, This circuit is going to take a lot of abuse because it's always on. The machine could be off, and there maybe not be power to the processor, or the RAM may not have power on it, and a lot of other circuits may be shut off. But this circuit's going to be on until you take the machine apart and disconnect the battery. This circuit's on. So this circuit takes a lot of abuse, and anything connected to this circuit takes a lot of abuse. And if there's water around any of these 3V42 pads on any of these chips, right, that will actually start electrolyzing the metal, because it goes from positive to ground, right? The electrons are going to start eating the metal and taking the metal with them, ionizing and connecting to it, and they're going to move the metal away to ground. And in the process, it's going to eat pads and eat traces. So this 3V42 area is a common area. When you have water damage, anything connected to it's going to take some abuse. So you always look for the 3V42 areas. And sure enough, on this chip right here, this pad was eaten off. So, okay, we pull the chip off, we fix the pad underneath there. In this case, because there was no pad, if you look at the actual chip, I don't know if I can zoom in on it. If you look at the actual chip, this whole area right here is that 3V42 line. And there's that line that goes in it. So because the pad was gone, I had to scrape array and run a little micro jumper, right, to get this chip to function. So once I got this chip to function, and my oscilloscope showed me I had a PCH clock. Awesome. So that's fixed. Still not booting. I'm still getting 300 milliamps when I plug in the charger. The power meter is just sitting there. It's not booting. So that's the third repair. I'm like, okay, if it's not booting, let's see if it's reading memory. Let's see if the problem is between the processor and the RAM data lines, or if the processor isn't even loading BIOS. So let's look at the BIOS. So I'm looking at the BIOS, and there are a couple data lines on this BIOS chip. 5 and 2 are your two data lines on this BIOS chip. It's a serial chip. That's why that's called SPI. I don't know if you can see that. That SPI, MLB IO0, and there's going to be an IO1 on pin 2. There you go. IO1 on pin 2. These are your two serial SPI data lines, and that's how you read this chip. So I watched this on the oscilloscope, and it's not reading. There's no data activity on here. There's no read happening. So for some reason, it's not connecting. So if you look at this circuit, it goes up here to the JTAG connector, which is something that Lewis screams about a lot. This is the JTAG connector, and this is an interface Apple put in so they can plug a programmer into it and connect to the board and diagnose it. This is their gateway that allows them to talk to this chip, allows them to talk to the BIOS chip, allows them to talk to the PCH. This is how they interface into the board. And I use this to change serial numbers and different things. So that data line was running up into this area, right? And hit that resistor, boom. Then after it hits that resistor, where does it go? Okay, it doesn't go to the processor. See, that's just a dead line. It's not connected. That's the other side of this line, right? The back side, that's why those are blue. And so it goes to this resistor, all right? Then where does it go? There it goes to the PCH. So it was looping through here first. And this had corrosion, which was also cleaned and looked like it was repaired. And so where's the 3V42 line on this thing? Well, there's the 3V42 line. That doesn't look anywhere close to those data lines. So let's just look and see how these could be damaged, because these were the problem. These resistors should be 43 ohms. They were very high. That tells me that current went through them, that it didn't want to go through them, and it damaged them. So let's take a look. So here's our SPI MOSI. This is the other one that takes off. Oh, wow, look at this. Through this resistor, it goes down to here. Okay? This is part of that interface that Apple uses. And what's right next to it? Ah, 3V42. So it's safe to assume that some corrosion created a short here, which put power on this one at 43 ohms. And then put power on this one, that's 43 ohms. This is a dead connection, this is 43 ohms, right? So we had 3V42 shorted on that data line. And you're like, yeah, so what? It didn't hurt the processor because the processor uses that 3V42 logic, no big deal. But by energizing these circuits with 3V42 and other things close by, such as ground, see, lots of nice ground near these two. So that corrosion energized this, ran current through this to ground somewhere, and the corrosion actually damaged the pads underneath these resistors. And these are 0102s. These are not very big resistors, see? Here's that area. Now let's zoom in and see how big those resistors are. Oh boy. Let's get back to the area that we're actually talking about. Oh my, look at that. So this is maximum magnification on my phone. I'm going to get my finger in here so you can see what I'm talking about. Oh, look at that. This is my finger. That is the tip of my finger. Wow. So the tip of my finger covers this whole area. That's how small they are. That's how small they are. So you get corrosion around in here, and you short out these resistors up in here. They got eaten up, and that broke the data line to the processor. So that is why the processor wasn't loading BIOS. So after I fixed that, now it starts reading BIOS, bam, fan spin, board boots up, works great. So just to recap, this had a blown 3V42 power supply. That was bad. And as you can see, that pretty much goes everywhere. Had a damaged SMC, probably because the voltage that was going to the SMC was too high because something was shorted in the 3V42. Fixed the SMC. After that, the PCH clock signal was missing because of damage to U1900. After that, the data lines were damaged up here around the JTAG. So this board had 4 problems, but it's fixed. And that's why I think it's important that when you work on these boards, when you get a toughie, you figure the toughie out, because that toughie helps you next time. You know, a lot of people never even get into the PCH clock. They don't even get into the data lines coming off the BIOS chip. They don't understand how it reads it and how it loads and how it boots. But it takes that level of understanding to get to the bottom of some of these boards. So I just wanted to, this is not the actual repair board. The actual repair board is sitting in that MacBook over there. But I wanted to go over this after the fact, just to show you that some of the fruit is not low hanging. So when people send their boards into some eBay guy for a $100 repair, do you really think he would waste his time to fix all of that on this board? No, probably not. In fact, I've seen several of those boards that have been sent to those types of shops that I fixed, because I do chase them down and I give every board a fair shot. So I just wanted to show you that with water damage, it's not always going to be easy, and you can't give up, and you have to chase the rabbit holes down. But you know, if you're in an area of a board and you don't understand what is going on, the way I learned about this BIOS section is I pulled the data sheet on the BIOS chip, and I learned where these lines were, and I learned how they were read, and I learned how they functioned. You know, so a lot of times to fix these boards, I can't tell you how important it is. You have to go out on the internet and pull up these chips. You know, so if we pull up this chip, you're like, well, it's not, how's it working? I'm gonna do Shift N to get to the next one. So here's the area we're at. There we go. This is the BIOS chip. So you have to understand how these chips function, and you have to understand these lines. You know, this is the 3v3 line. You have to understand, here's our data lines, our SPI, MOB, you know, and SPI is a nomenclature. It's like a serial interface. So reading the data set on this chip helped me understand how this chip functions. So when you get into a board and you're in unfamiliar territory, you have to stop and educate yourself and learn how that chip functions so you know how to troubleshoot it. You know, you have to learn how they work and why they work. It's not everything is going to be easy. Not everything is going to be, oh, there's a little spot of corrosion there. If I clean it, it fixes it. You have to actually chase down the rabbit holes. And sometimes you might be looking in an area where you can't figure it out and you have to back away. Another important thing to have is have a good working board to compare with. Like when I first started looking at the PCH clock signal, I have no idea what it's supposed to look like. But I grab a working board out of the box and I check it against my oscilloscope so I can see what it's supposed to be looking like, and that helped me understand and troubleshoot the next board. So it's really important, if you want to learn these things, that you go ahead and when you get stuck and you don't know, that you have to stop and pull up data sheets and educate yourself on these chips and how they function. That way you can troubleshoot it, and you also have another known good working board that you can compare against. So I just wanted to show you a repair that was high-hanging fruit and not easy. And I would guess that sending this board in, that, you know, this is not that board, but it's in that box right there. But this type of repair, if you sent this to 10 shops, I'm going to say 9 or 10 of them would total board. They wouldn't have gone there. A lot of repair shops I know of, once you get into the machine not booting or any type of data or 3v3 area where they're dealing with 3v3 logic, they're done. If they get into anything around this PCH, they're done. They're not going to do it. The Microsoft Management Engine, the MME, PCH section of this processor, and they're just done. Or a lot of shops, you get into changing SMCs, they're not going to do it. They're done. So I just, you know, if you're going to repair these, chase down the rabbit holes. And this was high-hanging fruit, people. But it took probably more time than I make money off of it. But it's okay because I learn a little bit in each one. I like the toughies. The toughies teach me. That's it for today.